Hi, today my name is Howard Lim, and today I'd like to show you RC time constant circuit by LTspice program. Now in the window, there will be like a voltage input, voltage output, and the voltage across the resistor and the current across the resistor, and then finally all combined graph in one window. Okay, so first of all, this is the LTspice window. So what I would like to do is I'd like to add uh, drawing window. So from there, now I'm gonna show the graph. Okay. So first, I'm gonna bring it down, click in the resistor here. Okay, and then now I'm gonna bring capacitor down there. Okay, and then it's a little bit make it smaller. And I like to bring it in a voltage source, which is here. So I just add here. And then I like to add a ground, which is right under here, negative. And the other one is for to add. And then after that, like I like to add a line. So when I draw the line starting from here, continue here, just go there. And then after that, just continue here, click it. Okay, so okay. Circuit is completed. Then I like to add network name. So one is voltage input, and then I'm going to set port type is input. Okay. So let me add this one to about here. And then after that, like I like to add voltage output. So it's gonna be voltage output. And then port type. Port type is output. Okay. So let me add around here. Okay. Then after that, like I like to connect the wires. So let's say connect here and bring it there. Okay. So I add a voltage input, and then I'm going to add the voltage output. So I'm going to add this one. Okay, so now I completed it. Then I like to add the value starting from the voltage input, which is pulse input. So what I'm gonna do, I'd like to add this one to pulse. Then there is this value supposed to put it in. So I put the value as starting from 0, and the on is going to be 10 ohms, right? And then after that, like time delay is 0.5 millisecond, but time total time rising time is I just put 0.5 nanosecond. Again, 0.5 nanosecond, 0.5 nanosecond. And time is I put 0.5 millisecond, and together the period is 1 millisecond. So set up, and 1 millisecond. Number of cycles is infinity, so I just click here, OK. So now let me move this one to a little bit the right position. I say about here. Okay, so then now we just here around here. So and then after that, I like to add the value. So which is now R is 10 ohms, right? Set is given, and then capacitor value is capacitor value is oh, so capacitance I put 1 microfarad, right? Okay. So all set. Voltage input, voltage output. Okay, so now I want based on this one, and then configuration is so what I like to do is I like to configure. Okay, so stop sign means I need a stop sign 2 milliseconds. Okay, so 2 milliseconds. Okay, so I'm gonna put over here transition times 2 milliseconds. Okay, so all set. Then I'm gonna run it. Okay, so and then on the right side, let me on the right side, let me make it fit the window. Okay. So, and then after that, like, I like to plot setting. It's just to add for this voltage output. I'm going to put on the next one is a voltage input. And another one is the voltage across the resistor. Another one is current across the resistor. And then the last one, I like to use this one for combined all of them. Okay, so now first one, I just add a trace. So that's the voltage input. Okay. See, now you can see from 0 to 10-volt pulse. Okay, and then after that, like on the bottom, you see times. And now I'm going to add more to the second one. This time voltage output. Okay, so it's voltage output. So now we can kind of change the color so I can see better. Okay, so, okay. Next, then after that, like I like to see the difference for voltage across resistor, which means the difference between voltage input and output. So what I'm gonna do is add a trace voltage input minus voltage input minus voltage output. Oop. Voltage output. So making sure there's no space between. This is that two different. Okay, so now you see the voltage, the difference between input and output. That is across voltage across the resistor. So let me change the color to different color. Okay. Okay, so what I like to do here is now I'm going to add some, this, what it means, like a voltage. This one is actually voltage across our resistor 1, right? So that equals. So I'd like to add this one in front of here. So, okay, so voltage across the resistor is voltage input output. And that is the difference between voltage input, voltage output. Then the last one is I like to add the trace current across resistor. Okay, it looks the same shape as the voltage across resistor, but actually it has a value of H, which is 10 divided by um, the voltage. Actually, the difference is actually 0, but that's why I follow exactly same. I will catch the uh, current amp current ampere. And then after that, like the last one is just to add all traces, right? So I'm gonna add input, no, input. So input voltage, input. Let me try again. Voltage input and the voltage output. And then voltage input minus voltage output. So it's minus voltage output. So, and then after that, like current across the resistor. So, okay. See, now as you can see, there are all the graph in one place. Now, when I change the value of this resistor from 10 to 60, then all the graph, okay, and then after that, I just click the run, then you see all the graph has been changed accordingly. Then I change it from 60 to 1000. Okay. Then after that, like you see the graph is change again accordingly because now resistor value is getting higher. So obviously the output, all the output is changing. And then if I change to value to 10,000, then it become more clearly. You can see the difference from here to there. See, it's more sharper, and actually voltage output um, voltage is, as you can see, like getting sharper. And see the graph. Now, when I change the pulse from minus to 5, and then so I'm going to change this one. Okay, so let me, oh, okay, so let me change this one to, um, let me change to input. Okay, so let me change this input voltage from minus 5 to minus 5 to 5, right? 5. And then time delay is 0. And after that, like everything's 0.5, 0.5 nanosecond and 0.5 millisecond and 1 millisecond. So that will be okay. Then now after that, like let me change this one to value 10, back to 10. Okay. So now there's been changed here, or so the last one graph has been changed. So let me this one. Okay, run. Okay, now the last one's been changed. So what I like to do is here, let me erase it. Okay, delete this trace. So everything's okay. V in, V out. And you can see minus 5 to 5 and voltage across the resistor and then current across the resistor. Then let me change the color here. So change the color pink, so more visible. And then here, so what I like to add it, I like add voltage input, voltage output, and then voltage input, and minus, and voltage output, voltage output. So I like to eliminate the space. And then after that, current across the resistor. No. Current across the resistor. Current across the resistor. Okay, so, okay. See, now you can see all graph is in one place. Okay, so this is for resistor values 10. So I'm going to change this one to 60. Okay, and then okay, and then I'm going to run. Then you see the graph has changed it. Again, when I change this one value to 1000, then run the circuit, then you'll see the output. And when you run the value to 10,000, okay, then after that you see run will be like that. Okay, so this is all the circuit output for the V input, V output, and the difference between these two, which is the resistor, the voltage across the resistor. So, okay, let me see. Okay, and now that's it. Okay, so all this output and the circuit has been captured the screen and finished it. Thank you.